Hello, and welcome to the Math Connection. I am Miss Lenz, and we are going to learn another method for multiplying polynomials. So we have already talked about one way that we can multiply polynomials, and that is by using the distributive property. If you want to see a video about how we can use the distributive property, you can click on this link that's up here, and it will show you how you can use the distributive property to multiply polynomials. But I'm going to show you another method today. It actually is using the distributive property. It's just kind of organizing it in a different way, and it is called the box method. Okay, so let's take a look at how the box method works. So we are going to be multiplying. Let's multiply x plus 4 times x squared plus 9x minus 2. So it's really important in these to understand what kinds of polynomials we're multiplying. Our first factor has two terms. Remember, that's called a binomial. Like a bicycle has two tires, a binomial has two terms. Okay, so our first one is a binomial. Our second one, underlined in green here, is a trinomial because it has three terms. So we're taking a binomial times a trinomial, two terms times three terms. So the box method needs a box to start with. And my box, since I'm taking two terms times three terms, we have to have a 2 by 3 rectangle. Okay, so I'm going to make this one have 2 rows and 3 columns. Now you could have done 2 columns and 3 rows. It does not matter which one you do. Okay, so I could have like a tall skinny rectangle, or I could have this rectangle. So what we're going to do is we're going to take our term that has 2 and we're going to put it on our side that has 2. So x plus 4 has 2 terms. So one of these is one row is going to be an x and the other row is going to be a plus 4. I'm putting one term per row. Now that factor does have to go on that vertical axis because there's 2 terms, and that was the side that had 2. I had 2 rows. For example, if I wanted to put it up here, x plus 4, I have this leftover one and I can't have that. Okay, so you have to make sure that you match up the sides with the number of terms that each factor has. Let's do the same thing for our factor that has 3 terms. 3 terms is the second one, and I'm gonna put one term per column. X squared goes in the first column, plus 9x goes in the second column, and minus 2 will go on our third column. Okay. And now what we're going to do is we're going to multiply. I like to think of this kind of as a Punnett square, like you might use in science class. We're going to multiply rows and columns to get what goes in that box. So in the top left box, we're going to be multiplying x squared times x, and that's what's going to give me that top left box. X squared times x is x to the third power. The next box over, I'm taking 9x times x. 9x times x gives me a 9x squared. This top right hand box right here, I'm taking negative 2 times x, which gives me a negative 2x. Okay, that's the first row. And essentially what I did in that one was I took this term right here, times all 3 of the terms in the top. So this is just using the distributive property, but it just is organized in a little bit different of a way. Okay. Let's look at our second row. We're going to start by taking x squared times positive 4. X squared times positive 4 gives us a positive 4x squared. Middle bottom, I'm taking 9x times 4. 9x times 4 gives me a positive 36x. And my last one, bottom right, I'm taking negative 2 times 4, which gives me a negative 8. So this is doing all of my distributing for me, just organizing it like this. And now I need to look for any like terms that I have. So my question was on the outside of my box. Here was my question, right? And so the answer to this is going to be inside of my box. That's where my answer is. So I need all of these terms that are inside of here. They're going to be in my answer, but I do need to combine my like terms. So I'm going to go in order from greatest exponent to least exponent. So x to the third power is my biggest exponent, and there are no terms that are like that one. So x to the third is going to be the first term in my final answer. And then I'm going to look for x squareds. Well, I have two of them and they are diagonal. So I'm going to combine those two because those are like terms. 9x squared plus 4x squared gives me a positive 13x squared. Other like terms that I have are my x's, and that's the next term I want to write. So I have a negative 2x and a positive 36x. That gives me a positive 34x. And then that minus 8 that's at the end right here, that one doesn't have any terms that are like it, so that one will just come down at the end, minus 8. And this right here is my final answer. Now, if I would have just distributed, I would have gotten exactly the same answer. This is just a different way of organizing it. Okay, so in this one, we took a 2-term binomial times a 3-term trinomial. Let's try a trinomial times a trinomial, or 3 terms times 3 terms. So this will say multiply. It also might say expand. Let's take 2x squared minus x plus 6 times x squared plus 5x minus 1. Okay, so again, it's important to understand how many terms are in each of these polynomials. Our first one, this one in red, has 3. And our second one has 3 as well. So we're taking 3 times 3. So when I make my box, I need to have a 3 by 3 box, 3 rows and 3 columns. Okay, so let's get that. 3 by 3. There's 1, 2, 3 rows. There's 1, 2, 3 columns. And now we're just going to take each factor and we're going to put them on the outside of our box. This one doesn't really matter because both rows and columns is 3, so the factors could go on either of them. I'm going to take my red one here and I'm going to put it on the vertical axis. So I'm going to go 2x squared minus x plus 6. Each term gets its own row. And then I'm going to do the same thing with my other factor. Each term is going to get its own column. So the top will be x squared plus 5x, and then we have a minus 1 at the end. And now I'm going to do my multiplication. I'm going to multiply the rows and the columns that line up for each of those boxes. So my top left-hand one is taking x squared times 2x squared. X squared times 2x squared will give me a 2x to the 4th. Next one, 5x times 2x squared is 10x to the 3rd. And the last one, negative 1 times 2x squared is negative 2x squared. That's my top row. Again, essentially what I did was I took 2x squared and I multiplied it by all 3 of those terms in the second one. So this is just distributing. It's just organizing it in a box instead. Okay, let's move to our second row. Second row, negative x times positive x squared. Negative x times x squared is negative x to the 3rd. Middle box, 5x times negative x is negative 5x squared. And the last one is a positive 1x, which I'm just going to leave as plus x. Bottom left-hand box, we're taking x squared times a plus 6. X squared times plus 6 gives me a positive 6x squared. Middle box, we have 5x times 6, which is 30x. And lastly, negative 1 times negative 6 is negative 6. So I've done all of my distributing or my multiplying, and now I need to combine like terms. So again, let's start with our biggest exponent. Our biggest exponent is right here, 2x to the 4th power. 2x to the 4th power is just going to come down in my final answer because there's nothing that I can combine with that. Next one is x to the 3rds. These two right here that are diagonal. 10x to the 3rd minus 1x to the 3rd will give me a positive 9x to the 3rd. My x squared terms in the middle, again, they're diagonal. Negative 2 and negative 5 gives me a negative 7. Negative 7 and a positive 6 give me a negative 1. Negative x squared is what I'm going to leave that one as. My next ones are positive 30 and positive x, or positive 1x, which will give me 31x. And my last term is just going to be that constant term, minus 6 will come down at the end. And this is my final answer. So this is what I get when I multiply those two trinomials. Now, if I was to make this 4 terms by 4 terms, I would do exactly the same thing. I would have a 4 by 4 square or box. If I was to have 3 terms by 4 terms, I would have a 3 by 4 box. No matter what, you're just going to find how many terms you have in your polynomials, and that's what your box will be. Okay? Thank you for hanging out with me today and multiplying polynomials. If these videos are helpful to you, please remember to hit that subscribe button. And if you want a short practice set for this, you can check out the episode description and there will be a link in there for a short practice set. It also gives videos for each of the answers. Thanks for hanging out and learning how to multiply polynomials using the box method. We'll catch you soon.